This is a beautiful slide.
Now we have arrived at the end of the stomach and the transition to the next organ. We see an abrupt change in the nature of the epithelium right about here.
Yeah. So to the right, we've got the stomach side.
Mm-hmm. So fluid's flowing out of the stomach.
Simple columnar epithelium.
We expect to find simple columnar epithelium when we zoom in there on the mucosa. Here's our mucosa of the stomach. There's a little bit of a submucosa there, and then muscularis, right?
Muscularis externa / propria.
That muscularis external layer expands dramatically
Big
right
swelling
here.
there, yeah.
Interesting. And then over here, there's a radical change in the epithelium here.
The shape of the thing,
mucosa, submucosa down here with some interesting, even at low power, we can see some interesting objects there. And then, wow, look at how the muscularis externa has thinned out.
Yeah.
But there it is.
Yeah. Okay. So this is another one of those abrupt transitions.
Mm-hmm. Right here.
But here we're actually going to go from simple columnar to
simple columnar.
To simple columnar junction.
That's my prediction.
Yeah, but just arranged very differently and doing very different things.
Okay, should we zoom in and verify?
Yeah.
Okay, so let's go right to 40x. Drop down a little bit. Okay, so these are our pale, mostly just pale mucus secreting cells lining the very end of the stomach. And if I can get up to the surface here, there we go. We see the surface of the epithelial surface of the stomach indented with gastric pits here. These are simple columnar cells, tall and skinny, a monolayer of cells. Okay? And that's what we've seen before in the stomach. Moving along, there is that very large expansion. I can go back to 4x here. Very large expansion of part of the muscularis propria right here. I think I see some lymphoid tissue right there, some lymphocytes. And then transitioning over right about here to a different epithelium. Let's take a look at that and note the distinguishing feature of this organ, a new one. What happened here?
Right. It changed orientation, so you've got a flat surface with upward projections and downward projections.
Okay, so ground level is like here.
Yeah.
And we have our subterranean little excursions like that one, and here's one, and here's one. So there are some what we call crypts now. But then there's these skyscraper-like towering extensions above ground level. So we have projections, finger-like projections into the lumen, and then indentations down below the sort of line of reference here.
So we have covered this in foundations to an extent. We looked at. We did.
Yeah, we covered. We were focused on the epithelium.
Yeah. So but we did look at these. We call them villi.
The finger-like structures, the skyscrapers. Yeah. These are unique to the small intestine. So we've left the stomach, and now we are in the
duodenum.
That part, the first part of the small intestine, is the duodenum.
Go on, you say it the way you say it.
Duodenum?
The duodenum, yeah. That's what I said.
That's what I said.
So we've got the simple columnar epithelium. We've also got now the appearance of goblet cells.
Right. So these what look like pale staining almost like little balls of wax. These are the goblet cells, and that's what they look like after fixation and H&E staining. We also see, even at this 40x magnification, we can start to see a little fringe here. The apical surface of these columnar cells are accented with microvilli. Microvilli. Should we zoom in and just remind ourselves what that looks like?
Microvilli on the villi.
Yes. Yeah. So we have villi. We have microvilli. I doubt. I'm going to drop out real quick. Just look at the whole slide. Yeah, unfortunately, we're missing the larger scale. If we saw the whole mucosa here thrown up into large folds, we would call those plicae circularis. Right. So there are not one, not two, but three levels of folding plicae circularis, which you can see macroscopically very easily. The villi, which are barely macroscopic, if you look very carefully at a carpet so that you can see the individual threads, the tips of the threads of the carpet, that's kind of what you see when you look very closely with the unaided eye at the lining inside the intestine. So those are the villi. And then that additional third tier of folding, that that forms the microvilli. Where are they?
Yeah.
Get that center.
Those are beautiful, actually.
Yeah.
And so this is all your theme of surface area.
You know, I was going to say it, but I'm so glad that you said it for me. The surface area, these three-tiered, 3 layers of folding increases the surface area of the small intestine from what you would have with a smooth tube to something that I think is something like 600-fold greater area for absorption of nutrients, secretion of mucus enzymes, and additional fluids, some of which are coming from, look at this, these glands.
Okay,
Down
not to be outdone by your theme of surface area, let's get back to my theme of defences.
Oh, it's over. You've
No,
been outdone.
We have these. These are a defining feature of the duodenum,
Okay.
which is these gland structures in the submucosa,
How do you know they're in the submucosa?
because they're surrounded by connective tissue.
Look at this right here.
And you've got a bit of muscularis
Yeah,
mucosa.
there's a little
up
broken,
there.
fragmented muscularis mucosa there. That's
Yeah.
the bottom of the mucosa. Now we're
Yeah,
down to
submucosa.
Right on.
So this is what is called Brunner's gland.
I'd say Brunner's.
Brunner?
just to
Just
just to be contrarian.
Yeah, okay. And these are a very important defense mechanism because they secrete a very alkaline solution,
Bicarb.
bicarb,
Yeah, bicarb.
to immediately neutralize the acidic chyme that is coming out of the stomach.
Oh, I almost forgot. If we go back to 4X and look at this. Over this large ridge here, we have the acidic contents of the stomach spilling into the duodenum. We had taken food that was at whatever pH it was, different diets, it can range from, 5 or 6 to 8-ish. We had stepped the pH down to like 1.5, super acidic in the stomach. That kills off a lot of potential pathogens,
Yeah.
a lot of microbes. And then here we are moving the contents of the stomach across this sort of gateway here into the duodenum, and we don't want that powerfully acidic solution eroding the lining of the small intestine here, of the duodenum.
Or else you
So-
get an
ulcer?
duodenal ulcer.
Ouch! That sounds
Yeah,
painful.
don't want that. So that gland there, Brunner's gland, sitting immediately after the pyloric sphincter.
They're neutralizing the acid.
Yeah.
Yeah, back up to 7
Defense
pH.
mechanism, along with the mucus coming from the goblet cells, adding a bit of slime to keep things moving along.
I mean, defense. That's just lubrication.
Wow, so it's a little bit protective.
We need some solvent.
You're going to say anything about the sphincter itself?
I am going to come back to this and just point out that if we look at the muscularis purpura of the stomach, we seem to have. I'm going to go ahead and suggest that there's certainly a discrete sublayer here, all the way out away from the lumen, and then there's some fascicles of muscle that look sort of organizationally a little different. I think we might look for our myenteric plexus in that region there. I think that's sort of a division between 2 sublayers. And then watch what happens. This what's presumably outer longitudinal muscle extends like this, and maybe it thickens a little bit here. This inner, what would presumably be inner circular, expands by 5-fold in thickness into a massive ring of smooth muscle wrapped around the end of the stomach. We call that
The end of the stomach.
the pyloric
The
sphincter.
pyloric sphincter.
And pyloris means gatekeeper,
Ah.
by the way. So this is the gateway out of the stomach and into the duodenum. We have strict control, careful regulatory control of the emptying of the stomach into the duodenum. Food can hang out in the stomach for up to 4 hours, getting sterilized and sloshed around, mechanically digested before, and we just release little bits of it to the
And is
duodenum.
it true that if you stuff your hand down your esophagus and into your stomach, you can palpate it?
Let's look at a clip. Give it a try.
You said you could palpate it earlier.
So in anatomy lab,
Oh.
where the students have recently opened the abdominal cavity,
You didn't say before that was in anatomy lab. I thought you could stuff it in your mouth.
I just let you assume things.
Okay.
Yeah, no, you can in the embalmed donor, where the muscle's kind of contracted and fixed in that state, you can even see by unaided eye, you can see the constriction at the end of the stomach. You can palpate it. It feels like a solid knot of tissue, because that's pretty much what it is. That's our pyloric sphincter right there. The expansion of the inner layer of circular smooth muscle into a massive ring that can constrict the exit to the stomach.
Okay, so we've got a very well-defined junction here.
Mm-hmm.
Both simple columnar, but very different in organisation.
Mm-hmm.
And now we're looking into the concept of increasing surface area for absorption of
We're
the
definitely doing that.
broken down smooth, and that's the story of the small intestine, really.
Indeed it is.
We've neutralised the acid, and off we go.